What's going on, guys? Welcome back to our GCSE psychology journey, and today we're going to be looking at structure and function of the nervous system. Let's go. So we're going to start off by looking at structures of the CNS, or the structure of the CNS, that's the central nervous system. So a quick overview. The nervous system is divided into two parts. You've got the central nervous system, or the CNS, which is made up of the brain and the spinal cord. And we've got the peripheral nervous system, or the PNS, and that is all of the nerves outside of the central nervous system, or the somatic and the autonomic nervous system. We'll look at those in a little more detail. So what protects the central nervous system? Well, we've got the skull, as we can see here on the screen, and our vertebrae. So the skull and the vertebrae are bony structures, and that provide physical protection to our central nervous system. And remember, our central nervous system is our brain and our spinal cord. But let's look a little bit deeper than the skull. So beneath the skull, we've got what are called the meninges, and these are three protective membranes. Number one, we have the pia mater, which is a thin inner layer, and it's very closely attached to the brain and the spinal cord. That's the pia mater. We've got the arachnoid mater, and that is the middle part there that looks kind of like a web. So if you think of arachnoid, so it's like spider, so think of a spider web. And we've got the dura mater, and this is the tough outer layer. If you think durable, something that can withstand a lot of punishment, it's very durable. So the pia mater is this one that we can see here. The arachnoid mater is what we can see here, this web-like substance, this web-like layer. And our dura mater, which is the tough outer layer. So those are the three protective membranes known as the meninges: the pia mater, the arachnoid mater, and the dura mater. We've also got cerebral spinal fluid, or the CSF, which is a fluid that cushions the brain and spinal cord. It also removes waste and provides nutrients to our central nervous system. We also have our blood-brain barrier, and this is selectively permeable, so it protects the central nervous system from harmful substances. So let's look at the spinal cord itself. So in this illustration here, we can see that our spinal cord, and we can see that it is protected by our vertebrae. The spinal cord is a bundle of nerves running from the brain stem all the way down the spine. The function is that it acts as a relay station between the brain and our body. So what are the structures of the peripheral nervous system? So let's look at those in a little more detail. So we've got two main divisions of our peripheral nervous system. We've got our somatic nervous system, or our SNS, and our autonomic nervous system, or our ANS. So we've got our somatic nervous system, or our SNS, and this controls our voluntary movements. It connects our sensory receptors and skeletal muscles to our central nervous system, and it transmits sensory information from our sensory receptors to our central nervous system. And we have our autonomic nervous system, and this regulates our involuntary functions, so things such as our heart rate, our digestion, how our glands behave. And this is divided up into two branches: our sympathetic nervous system and our parasympathetic nervous system. We're going to look at those in a little more detail. So our sympathetic nervous system, also known as our fight or flight. Now what this does is this prepares us to act. This is what kicks in if there is a threat detected. So it increases our heart rate so that our body's got more oxygen. It dilates our pupils so we can take in more information, and it inhibits digestion, because if a tiger walks into the room that we're in, our body's saying, listen, we don't have time to be digesting food. We need to think about getting out of here, so we need to use those resources in ways that are going to help to protect us. That is our sympathetic nervous system. And our parasympathetic nervous system does the opposite. So that is our rest and digest. So this conserves energy, it slows down our heart rate, and it re-stimulates digestion. Right? And it brings us back to what we call homeostasis, which is when our body is at its normal way of being. So the James Lange theory of emotion. So according to James Lange, he argued that emotions are the result of physiological changes in the body and not the cause of them. It was proposed independently by William James and Carl Lange in the late 19th century, around the same time. They believe that different emotions are linked to different patterns of physiological arousal, and the brain interprets these bodily changes to create that emotion. It says that emotions are not automatic mental states, but they depend on our body's reaction. So the core idea is We get a stimulus, so for example, we see a snake. We have a physiological change, so for example, like our heart rate increases or our muscles tense. Following that physiological arousal, we then interpret that emotionally and we think, okay, well, we're gonna apply fear to that as the emotion. So stimulus, we see the stimulus, we see the snake. We have a physiological state change, so we become physiologically aroused. Our heart rate increases. We interpret that as the emotion of fear. So what's some of the strengths of this theory? Well, it highlights the important role of physiology in emotion. It's supported by evidence that bodily changes, for example, heart rate and sweating, are linked to emotional experiences. What about weaknesses? So many emotions share similar physiological responses, and that makes them hard to distinguish. If you're excited, your heart beats faster. If you're afraid, your heart beats faster. People with spinal injuries still report emotions, suggesting physiology isn't the whole story. Emotions can sometimes be felt before any noticeable bodily change. Right? So sometimes we feel emotions, but we don't have that physiological change starting off with. The Cannon-Bard theory. So the Cannon-Bard theory of emotion states that emotions and physiological responses happen at the same time, and it isn't one that causes the other. So according to this theory, when we encounter a stimulus, for example, back to the one of the idea of us seeing a snake, the brain simultaneously triggers the emotional experience of fear and produces the physical response, so increased heart rate, sweating, and these things. And unlike the James Lange theory, Cannon-Bard argues that bodily changes do not cause emotions. Instead, both occur simultaneously in response to the stimulus. Alright guys, so hopefully that short video gives you guys a better understanding of the topics we just covered. Look over it again, take your time, rewind the certain bits that you need, make your notes, and I'll catch you guys in the next one. Peace.